Okay guys, so I'm going to start to go through some free response questions so that we can review for the AP exam. So I'm going to start with the BC 2019 free response questions. So I'm going to do question number 1. So let's see what we have that is important here. It's a calculator question. So we have a rate the fish enter the lake with this function. And the rate at which they leave the lake is this function right here. This is important. We're both measured in fish per hour, and T is in hours, since midnight. So letter A, they want to know how many fish entered the lake over 5 hours. And they're nice enough to tell you that's from time 0 to time 5. Give your answer to the nearest whole number. Remember, if you don't round correctly, you're not going to get full credit. So letter A, it's a calculator question. We know that when we integrate a rate, we get an amount. So when we integrate fish per hour, we're going to get how many fish entered the lake. So I'm going to integrate in my calculator from 0 to 5, the entering function. Type it right into your calculator. You're going to get, let's see what I got, this number, 153.457 ... But if we want to round to the nearest whole number, we're going to get 153 fish. So that is letter A, and that would be worth 2 points. A point for your integral, a point for your answer. All right, letter B. Now, letter B wants the average number of fish that leave the lake over the 5-hour period. Now, average in our class never means add two numbers together and divide by 2. It's asking for the average value, because when we integrate this that I'm writing right here, L of T, from 0 to 5, that's going to give me the amount of fish that left the lake. But now if I want it over a 5-year period, I'm going to multiply by a fifth or divide by 5. It does not say to round, so we're going to round to 3 decimal spots. And when we do that, we type this straight in our calculator, we show the integral, we're going to get 6.059 fish per hour. Okay, so now let's see what letter C has. So now letter C, at what time between 0 and 8 is the greatest number of fish in the lake? So that is asking me for the maximum, the absolute max, because there's an interval. So that's when we're going to set up our sign chart. Now, the number of fish in the lake at any time T is going to be the amount of fish entering minus the amount of fish leaving. But we know when we want to find maximums and minimums, we're looking at the derivative. E and L are already derivative functions because they're already rates of change. So we have the derivative. All we have to do is set the derivative equal to 0 and make my absolute max chart. So the rate of change of the number of fish in the lake at any time is going to be the amount rate entering minus the rate leaving. And we're going to set it equal to 0 because that's how we find max and mins. And you're going to use your calculator to see when this happens. Type this one function into y equals, this into y2, and then you can see where they intersect. Because if you set it equal to 0, add 1 over, you could see where they intersect. Now that happens at time 6.20356. So that is a critical point. Now, what goes in our chart? Remember, what goes in our chart is the critical points and the endpoints. So our endpoints are 0 and 8, and our critical point is this. Now, obviously, at time 0, there's going to be no fish in the lake, and I think the question says that. Or you could just integrate from 0 to 0, and there's no fish in the lake at any time by the properties of integrals. So at time 8, to find out how many fish are in the lake at time 8, we are going to set up this integral. We're going to see what happens from 0 to 8, entering minus leaving in our calculator. When we do that, we are going to get 80.91998 fish. The same for at time, this time right here. We're going to set up an integral from 0 to this decimal, 6.20356. Enter, minus leave. And we're going to get, let me pick a different color so it stands out, if it will let me. There it goes. That one. We're going to get 135.01492 fish. So, the greatest number of fish in the lake is at this time right here. At time 6.204, because we're going to round to 3 decimal spots. Okay? And now letter D is the rate of change in the number of fish increasing or decreasing. So anytime they want to know if a function's increasing or decreasing, we're going to look at its derivative. But now they're asking if the functions, which are already rates of change, is increasing or decreasing. So it's asking you to derive what they already give you. Okay, so I'll do that in a different color just so it stands out over here. So letter D, if I want to know what's happening at time 5, well, the number of fish in the lake at any time is entering minus leaving. So the rate, seeing what happens to the rate of change, is the rate, oopsies, too much, is the rate at which we are entering at time 5 minus the rate at which we're leaving at time 5. Type it into your calculator. You should have these functions in y1 and y2 already. We're going to get negative 10.7228. Well, that's less than 0, obviously, so we are decreasing. That is enough work right there. Okay, so I'm going to skip number 2 because it's on polar, and that's not on your AP this year. So we're going to go on ahead down to number 3 without a calculator. So we have a continuous function on this interval, negative 6 to 5, and it gives us a graph. This is always important, how they define the picture. So we've got 2 line segments and a quarter circle centered at 5, 3, and then this must be useful for something later on. So letter A tells us that the area under the curve from negative 6 to 5 is 7. They want us to find the area under the curve between negative 6 and negative 2. Show the work that leads to your answer. Now it's not as easy as just finding the area under the curve because this curve starts at negative 2. So we have to use properties of integrals. So if you look here in the orange, I set up an integral. The entire area is going to be made up of 2 parts being added together. The area from negative 6 to negative 2 plus negative 2 to 5. Now why did I split it up over negative 2? Because the question's asking us the area from negative 6 to negative 2. Now, this integral right here, they give us that area. That area is 7. We don't know this area right here, so I'm going to leave it alone. Plus the entire area from negative 2 to 5. So now this is where I need to find the area under the curve between negative 2 and 5. So this little triangle is very easy right here. It's 1/2. Now this triangle, here's the issue. We have to figure out where this crosses the x-axis. Now if you assumed 1/2, you just got lucky. How do I know that it's truly 1/2? I found the equation of this line right here by finding the slope, y equals mx plus b form, and then I found the x-intercept, which is in fact 1/2, 0. So the area of this triangle is negative 0.75 because we're underneath the x-axis, and the area of this triangle is 2.25. And now to find the area of this shaded blue region, I took the area of the entire square minus the area of this semicircle, and I got right here. The area of the square is 9. This is not the semicircle, I'm sorry, the quarter circle is going to be 9 pi over 4. So now I need to add this stuff all together. So we are going to have, oopsies. Okay. 7 equals this plus, when we add the triangles together, we're going to get 2 plus 9 minus 9 pi over 4. Now this is a non-calculator question. So when you actually solve for this integral here that I'm underlining in black, I'll write the answer right down here. You're going to get 9 pi over 4 minus 4. That is our answer for letter A. All right, letter B, we have done a lot of these questions. So first thing you have to do for letter B is you have to split up the integral. So we need to go from 3 to 5, pull the 2 out in front, f prime of x dx, plus the integral from 3 to 5 of 4 dx. When we integrate a derivative, we're just going to get back to the function. So this first integral is just going to become 2f of x from 3 to 5, and this second integral is just going to be 4 times the area under the curve between 3 and 5. So, oh, I'm sorry. I don't know what I'm talking about. Has nothing to do with the curve. We're literally just going to integrate 4 to become 4x from 3 to 5. You're going to plug in these numbers, do the math. F of 5 is equal to 0. F of 3, that's why they give us this coordinate right here. So we're going to be doing 2 times f of 5 minus f of 3 plus 4 times 5 minus 4 times 3. You are going to get a final answer of 2 plus 2 at 5. To find f of 3, guys, you need to use this coordinate right here. Okay, letter C, they want the absolute maximum. So we are setting up a chart right here with our endpoints and our critical points. Now, how did I get those critical points? I want the absolute maximum of g. So we need the derivative of g, which is the fundamental theorem right here. When we derive g, we're going to get f of x because we're going to replace t with x. We're going to set that equal to 0. Well, that's the graph of f. Figure out where we equal 0. These three values right here. Put them in my chart. Now, to find g of negative 2, we're replacing x with negative 2. Well, we know the integral from negative 2 to negative 2 is 0. And then the rest of them, it's asking us for the area under the curve between negative 2 and these values. We already found that. We plug it into our table, and then we circle the one with the highest y value. So the absolute maximum is right here. And now letter D, it's asking you for a limit. We know to evaluate limits, we replace x with the number. So I did it here in green. Well, f prime of 1 is the slope of the line in the graph of f. Arctan of 1, we do not deal with degrees, is going to be pi over 4. How did I find f of 1? I looked at the picture. Plug it in, leave your answer like that, and there's another AP question done.